so let's try and remember what we did yesterday. So our question says solve the equation cos x equals negative 0.5. So I've drawn for you already the little sketch of the cos curve. Remember 0, 90, 180, 270, 360, up to 1 down to negative 1. Standard sketch. We're trying to solve it when it's equal to negative 0.5. So what's our first thing we would have to do now?
Find negative 0.5.
Yep, so we're going to find negative 0.5. So I can see that here. Oh, look, there it is. I found it. Now what do I do?
You can draw a line to the cos.
Draw a horizontal line. Excellent.
Good job,
Now, does it matter if our line is perfect?
No.
As long as it's in the rough vicinity, that's fine. Okay? Obviously, this is easier to do because I've drawn you the graphs. They're not just baby sketches. But it's going to be just as easy when you're doing it, I think. What are we actually trying to find now? We're trying to find this number here and this number here. Okay, so we're trying to find these two missing values. That's the aim of the game. In other words, which value would I stick into here? When I press cos of that number, does it give me an answer of negative 0.5? What did I say you had to do to find one of the values? Calculator, yeah. So we're going to stick into our calculator what?
Cos of minus 1.
Nice.
Negative 0.5.
Negative 0.5, yeah. So, remember yesterday I think we put our calculators in radians to draw those sketches, so make sure you're back into degrees when we're doing this. So you do need to be comfortable switching forward and back from degrees and radians.
Wait, we need to be in degree for this?
Yes. Right, so we got 120, yes?
Yes.
Which one of those two is the 120 one?
The second back one. No, the first one.
Okay, this one here. Yeah.
You shouldn't copy me.
Now, how did we find that other one yesterday? We looked at we looked at the symmetry bit, didn't we? Yes? So where is this graph symmetrical?
In the middle.
Okay, awesome.
Wow. In the middle. Good job.
So we've said that this measurement here is 120.
Oh, and then
So what's this? Where's going to be 120?
60 minus 120.
Yes, Jennifer.
2 points. Good job.
Are we happy with that?
Yeah. Wait, so we did 160 minus
No, 360.
that's what I meant to say. 360 minus 110.
Yeah. So our answers are x equals 120 and 240. Now, at this point, I want to bring in the interval business, because up until this point we haven't really talked about it. In the first question and the second question, okay, so the first example it had x is between 0 and 360. This example is x is between 0 and 360. So answers that you give have to be in that interval range. So that's fine for this one. This one is different. Okay? So we're looking at a different interval range, which means that our answers, we need to think a little bit more carefully about our answers. So whilst I often say to you, don't worry too much about this extra information, it's just kind of technical stuff, for these kinds of questions it is important. So this is our first tan question. As I said, they don't come up that often, but we do need to appreciate what what's happening with them. So again, I've sketched you a tan graph. Okay, so the red line is the tan graph. You all happy with that? Hopefully it's not too... Oh, does it?
Yeah.
Oh, that's annoying. I use a colour printer.
Perhaps
The shades are obviously going. Maybe you want to do different colours on top of it then, I don't know. So obviously there's my axes. So the negative 90, 90, 180, 270, 360. What do we call these vertical dotted lines again? Nice, good. That means that there's nothing happening at those values. So we've got our sketches. We've drawn our horizontal line at the value of 2 because that's what we always have to do. Again, with tan, doesn't matter where the number is. It's just whether it's positive or negative. And we can see that we're trying to find this value and this value to start with. So, first one we do on the calc. How do we find it? We input into the calc what?
Tan minus 1.
Tan minus 1 of?
63.
No, tan minus 1 of? 2. Gives us 63.
0.
Oh, is it 0.0 yet?
Yeah, no, it's not. It's like 0.4. 434.
Oh, then we should have 0.4. We should be specific.
I messed this one up.
Now, for this one, it's not necessarily so much looking at symmetry, but remembering how this pattern repeats. Because if this is one of our bits of our graph, this bit is going to be the same as it, yes? So it repeats every 180 degrees. Do you remember that? So all we need to do is, if we've got this one is 63, to find this one, we're just going to do 180 plus 63. Does that make sense?
Yeah.
What's going on? Okay, so 63, and then this one would be 180 plus 63. Yes? Good. Are these two the only solution within this range? No. If you remember, the graph keeps going on and on and on forever and ever and ever. So, how would I find any values in this direction? Subtract.
180. 180.
Why are we subtracting 180?
It's the opposite.
Because it repeats every 180 degrees, yes? So if you're trying to find this direction, we add 180. If you're trying to find this direction, we subtract 180. Yes, makes sense? So we're going to do 63, subtract 180. What do we get?
Negative.
Ooh.
117. If you were to go that way.
Because just now, up here, our range is between negative 180 and 720. So we have to give all of the solutions in that range. Okay? So that's within that range. If we took away 180 again, we'd go past that, yes? That's an obvious one, isn't it? If we add 180 to this, are we still within our range?
Yeah.
Yeah, so you're going to have to keep adding 180 until you've given all of the values within that range. You're happy with that? Yes?
So what is the 63 for?
That's one of your answers. So for this, you're going to have x equals negative 117, comma, 63, comma, 243, comma. Yeah.
Oh.
It's really sensitive to make that word.
I didn't do anything.
Depends on the phone.
All right, so they're all our solutions. Yeah? So we're used to giving 2 solutions. We're not necessarily used to giving so many. Just make sure you're repeating until you get out of your range. Next one.
Pull my back.
Now, again, I helped you out here. I probably shouldn't have done this. I probably should have done it how we would normally do it. In that, I've helped you out because I've actually drawn the graph for the range that we're interested in. Okay? So I actually drew it from negative pi to pi. Your gut instinct would probably be to start at 0 and go up to 2 pi. So I'm annoyed with myself right in this second for having done that. But anyway, don't forget that the radians sometimes come in. Okay, so this one I've drawn with our intervals. So remember it's pi over 2, pi, what's the next one?
3 pi over 2.
3 pi over 2, and then 2 pi. Alright, so as I say, I've drawn this one for you going into the negative part. You all happy with that? So we're looking when sine x equals negative 0.7.
Negative 44.
So hang on, so where am I going to draw my line?
Where did you come from?
Down here somewhere, yeah?
Wait, what? Why?
Because it's negative 0.7. Now, this is where you have to make a choice. Okay?
Sounds like the Hunger Games or something.
Your choice is, are you good at working in radians, knowing that this means negative 3.14, and this means half of negative 3.14?
Yeah.
Are you better working in degrees and then changing your answers to radians? Okay, so you have to make a choice as to where your brain's best suited, and that's going to determine how you do your working. But you must make sure your final answer is in the correct mode. Okay. Now, if you are more of an inclination to degrees, because they're nicer numbers, they're bigger numbers, and you know that you're adding and subtracting from 180 or 360 or doing those kinds of business, then you need to make sure you're working in degrees and you keep your calculator in degree mode. But your final answers you must change to be radians. If you're like, I can handle this, I'm good, I know what these things are, you can work in radians. So you would change your calculator to change this, so you would change it to be in radians, and you would solve sine to the -1 of negative 0.7. Okay, if you want to keep it in degrees, you're going to get a different answer, because obviously one of them is in degrees, one of them is in radians. So I'm going to go through both of them with you, and you can make a choice which one you write down. Yes?
And it has to be in radians.
Your final answer has to be in radians.
But we didn't put the other ones in radians.
No, because that was in degrees.
That was already in degrees. Like in radians.
Are you hearing me, sister? Yeah. So at the top, where that range is, because that's pi's, it tells you it's radians. So this one we have to make sure our final answers are in radians. All right, so let's work with the degrees first, shall we? Yeah? So, I'm sorry, pardon?
Negative 44.4. I had it burned.
Oh my God.
I didn't.
Okay, negative 44.4. So that's given me this answer here, yes?
Yeah.
How do I find this one?
Oh, you wanted to degree radians now?
Now, don't worry about the radians at the moment. What value would this be if this was degrees?
180.
Well, it'd be negative 180, yeah?
Yeah.
So how am I going to find this number here?
180 minus negative.
Plus. Negative.
180 plus, negative 180 plus.
Yes, you can do that. Negative 180 plus 44.4.
Or
Or you can do negative 44.4 take away, or plus 180, yeah. Okay? No, you will change the sign of it then. Okay, so what value do we get?
What are we doing? You confused us.
I confuse who?
Just a little bit. What are you doing?
I confuse everyone, because half the people told me. If I
Well, you
confuse...
confused me as much.
Wait, so are you doing 180 minus 4, not negative 40?
So we're trying to find this number here. Okay, so you could do negative 180 plus 44.4 to get that, yes? Because this measurement represents 44.4, so that would represent 44.4.
Negative 135.6.
Now, what I would like you to do when you're doing these is just know what were you going to type into your calculator?
What do you mean? Or was I going to type?
Well, what were you going to, how were you going to work out what that number was?
Was it negative 135.6?
Yeah.
I thought we did like negative 144.4 plus 180. I mean, the other way
Well, type it into your calc. Just do what you would do naturally. What I want to try and do is to get you to look at what you would do naturally and make sure that you've got the right answer from it.
I didn't get the right answer.
What did you get?
I got negative 224.4. So, what's
all right, okay.
I do 270 there instead of subtracting 180?
No, okay, so hang on a second. So when you say you got the wrong answer, would you have known you got the wrong answer when you were in the test? You would have just merely put that. Okay, so this is what we have to make sure that we are catching these mistakes. You should recognize that this is negative 180, and so this is not as far as that. It's got to be less than 180. So if you're writing down a number that 224, that should ring alarm bells and say, oh, hang on, I've done something wrong. Okay? So this is what I want you to do in the test. So whilst I can stand here and tell you what to type into your calculator, what I want you to do is to do what your gut instinct tells you and then work it out from there. Yes? So if you had done negative 44.4 plus 180, you would have got positive 135.6. And so then you can think, oh, hang on a minute, it must be negative because it's on this side. So there's lots of different ways that you can get this actual number, but you need to make sure you find the best way of doing it. Yeah? All right, okay, so we've got these two numbers. Sorry, Shel.
Since each point represents 180, okay. So you know how each square represents 180 essentially? Okay, how do I say it? From that point to that point is 180.
Yeah.
One point to the other. So couldn't I have just done negative
From there
44?
to there is 180.
From her to her, right?
From here to here is 180. So
That's
that's 180 here. So like that's 9. Yeah, no, wait. Yeah, that's 9.
Okay, but as Sarah just said, well, it's not in radians. So we have to remind ourselves how we convert stuff to radians. How do we convert stuff to radians?
It's something
Yeah.
Did you all hear that?
pi over 180.
Yeah, so what you do is you do negative 135.6 multiplied by pi over 180 and negative 44.4 multiplied by pi over 180. So, what are those two answers?
Wait, what?
Ah,
Oh, yes.
I'm not sure where I stopped recording. Yes, perfect, because I wasn't recording it. So we're in radians. We did sine to the minus 1 of negative 0.7, and we got negative 0.775. Okay? We now need to find this value. So this is negative pi, so we're going to stick into our calcs negative pi, but we need to work out what value is here. Now, remember, this measurement is 0.775. It takes us to the value negative 0.775, but that quantity itself is just 0.775, yeah? So that means that this quantity is 775. So to find this missing value, you'll do negative pi plus 0.775. Yeah?
Mm-hmm.
And did we all get negative 2.37? Yeah? So as I say, at that point, lots of people go, oh, well, that was way easier. But you have to think in terms of pies. And that's what freaks some people out. Okay? Some people don't like dealing with pies. But there's your two answers. So for this... Oh my God, what are you Alright, so again, another one, sine x equals negative 0.5. Okay, so we've got our sine graph, lovely jubbly.
Oh, it's degrees.
And we're back to degrees. So our first thing, what do? We've sketched it, la la.
You say negative 1.
No, not yet. What's the very first thing? We've drawn our sketch.
Calculator.
Not yet.
You draw your line.
You draw your line. Okay. Then, Jennifer,
Put in the calculator.
put in the calculator. So sine to the -1 of negative 0.5.
Second, third.
Right. Okay. So Olivia has got the value of negative 30. Now, is negative 30 in our range that we're interested in?
Yeah. No.
No. Okay. So this is where the calculator will always give you the value closest to the y-axis.
Is the line supposed to be on negative 0.5?
Yes.
It's a little confused. Her line's broken.
My line's too low. It should be along here.
Just thinking in my head, there's my dad.
Oh God, what's happened?
Look.
Sarah's dead.
So we are looking for these two solutions, okay? Because we're looking between 0 and 360. But we've just been told that the calculator's told us it's negative 30. As I've said, the reason that it does that is that the calculator will always give you the value closest to the y-axis or the closest value to 0. So in this case, it's told us that this bit here is negative 30. Okay? So what we have to do is say to ourselves, okay, well if that's negative 30, how does that relate to the other part of the graph? How this value here is 30.
Just on the other.
So this bit here, you're happy with that? Would also be 30. So that means that this number here is going to be 360 take away 30. Yeah? And how do I find this one?
180 plus
180 plus 30. Yes. Come on, people. I get so excited.
Okay.
So our values are 210 and 330. Tres bien. So, next one. Cos x equals 0.4. Okay? Now, you may be thinking, oh God, this is really boring, we're doing loads of them. But the more we do together, the more hopefully you're getting happy with it. So, our sketch. Okay, so we've done our sketch. It's a cos curve, we've gone from 0 to 360. So, what do we do first of all? Draw the line at
0.4.
Oh,
wait. I'm negative, dummies.
Hey.
You could all do it.
What we do negative plus I automatically went to your last.
I did it right.
All right, okay.
Cos minus 1, 0.04.
66.4.
At least that's the whole thing.
All right, how do I find the other one on the other side? Look at the symmetry.
You do 274.
You plus 66.4. No, you do
You
minus.
You
No.
do 274.
You do plus 66.4.
No, 270
You minus. You do 90 minus 66.4, whatever that is, and you.
Don't you do 360 minus
670.
66.4? I know what I'm talking
Okay,
about.
now Jen, what you said would have worked, but you're
Okay.
making life way hard for yourself because you found this little bit
Because I saw
and then
it.
added that little bit.
It's like made sense to me. When
It's-
I saw
Yeah,
it.
that's what I was thinking.
And that's totally fine. So if that's what you're going to do, that's fine. As long as you're doing it correctly, I don't mind. But what you need to make sure you're not doing is adding 66.4 to 270.
So you
Because if we look at the symmetry, this portion here represents 66.4. So if it's symmetrical, then this bit here represents 66.4. Okay? So it's going to be 360 take away that. You'll get used to seeing that for a cos curve, your second solution is going to be 360 subtract your first one. Okay? So for the cos, it's generally going to be 360 subtract it. You two? And what's that?
93.6.
Thanks. Oh my gosh. Yes.
Yeah, it was 360.
Right, so there are two solutions. Is that it?
No. Yeah. No.
Why not?
Negative 180, it goes all the way, yeah.
Good. So, again, look at the range. We need to make sure we've got connected them all. How are we going to find any that are to the left? What do we do to these numbers?
Minus 180.
Now, be careful. Why did we subtract or add 180 to the tan graph?
Because there's 180 apart.
Because they're 180 apart.
90.
That's 90.
This one, Chelsea, is they're 360 apart, remember? What's the fancy word that we call that apart business?
Wavelength.
Period.
The period or the cycle. So the period for the tan,
It's 180.
the period for the tan is 180. The period for the cos and sine is 360. So shelves, as she said, subtract 360 from these. So we're going to do 66.4, subtract 360, and we're going to do 294, subtract 360. What do we get for those bad boys?
Negative 29.
Negative 2 and negative 66. Okay, are either of these two in our range? Are they both? One?
One is.
Too far.
Alright, so our final answer is x equals negative 66.4. I guess, oh, that's because we rounded it. Anyway, negative 66, 66.4, 294. Okay, we getting the gist of this? This is just summarising then what we've been doing. So if it's sine x or cos x of something, to find the principal value, that's from the calculator. So that's where you do the inverse of it. Sketch it, show the one of your cycles, put the lines on there. Find the second solution using your graph, using symmetry. Then you're going to add or subtract 360 to find any other solutions.
For the question we just did, isn't there also a negative 294?
No, but that's not in the range, look, sweetheart. See, the range, it goes from negative 180. Yeah? For the tan, you're going to do the principal value from the calculator, and then you'll add or subtract 180 to find other solutions. Okay, so it's not too traumatic, hopefully, yes? That's if they're in degrees. Obviously, if they're in radians, you would be adding to pi or pi. Okay? Right,